Deep beneath the soil of every forest floor lies a clandestine, sprawling architecture that puts our man-made fiber optic cables to shame. This is the mycelial network, a vast web of microscopic fungal threads known as hyphae. While we see the mushrooms popping up above ground as singular entities, they are merely the reproductive fruits of a colossal, interconnected organism that spans entire ecosystems. This subterranean infrastructure is the secret engine of life on Earth, governing the growth and survival of the trees that loom above. The symbiosis between trees and fungi, known as mycorrhiza, is one of nature's most sophisticated trade agreements. Trees provide the fungi with sugars produced through photosynthesis, a currency of energy the fungi cannot generate themselves. In return, the mycelium acts as a biological extension of the tree's root system, scavenging for scarce minerals like phosphorus and nitrogen in the soil. It is a high-stakes barter economy, where the survival of the forest depends entirely on the efficiency of this subterranean supply chain. Beyond simple resource extraction, this network functions as a complex communication system. When a tree is attacked by beetles or ravaged by disease, it releases chemical signals into the mycelial web, effectively broadcasting a distress call to its neighbors. Nearby trees receive these molecular warnings and preemptively ramp up their internal defenses, producing bitter chemicals to repel the invaders. This is not just survival, it is the forest acting as a single, cohesive, sentient intelligence. Scientists have identified mother trees, the oldest, most connected hubs in the network. These ancient giants act as the central servers of the ecosystem. They prioritize the distribution of nutrients to younger seedlings that are struggling in the shade of the canopy, providing the literal life support needed for the next generation to take root. Without these central processing hubs, the forest would be a collection of isolated individuals rather than a thriving, resilient collective. The scale of this network is staggering. A single teaspoon of healthy forest soil can contain miles of fungal filaments. Researchers are now finding that these networks are not merely static, they are dynamic, shifting their connections based on the needs of the environment. The mycelium learns, adapts, and remembers, creating a persistent record of the forest's history within its physical architecture. We are only just beginning to map the complexity of this biological computing power. This discovery has profound implications for our understanding of evolution and competition. The classical Darwinian view of nature as a red-in-tooth-and-claw struggle for existence is being replaced by a model of cooperation and interdependence. The mycelium proves that organisms don't just compete for resources, they collaborate to create a stable environment. In the face of climate change, this network acts as a buffer, helping forests endure shifts in weather patterns that would otherwise be catastrophic. The implications of the Wood Wide Web reach into the future of human technology. Bioengineers are currently looking at mycelium as a sustainable material for architecture and electronics. Because mycelium can be programmed to grow into specific shapes and possess unique conductive properties, it offers a glimpse into a future where our buildings might be grown rather than built, living structures that can self-repair and communicate their own structural integrity. As we continue to clear-cut and pave the earth, we are unknowingly severing the ancient neural pathways of the planet. Every hectare of forest destroyed is a server room of nature silenced. To save the biodiversity of our world, we must move beyond protecting individual species and start safeguarding the subterranean networks that sustain them. We aren't just saving trees, we are protecting the oldest, most sophisticated internet in existence, the silent architects of our survival.